Okay, so in this problem, we're asked to propose a synthesis of this molecule starting from just benzene. So this is going to be a series of electrophilic aromatic substitution reactions. We've got three groups that we need to put on, a chloride, a nitro group, and then this acyl group here, an alkyl group, but with a carbonyl. So how are we going to do this? Well, we're going to have to put each group on individually. So we're going to have to do three separate reactions, one to put on each of these groups. And we'll have to do them in an order that makes sense to get the correct positioning, right? A para relationship between these two groups, a meta relationship between these two groups, and an ortho relationship between these two groups. We'll have to come up with some sort of order that makes sense so that the directing groups push everything else into the right position. But before we do that, why don't we review the specific reactions we're going to use to put on each of these groups. So we're going to start from benzene, but let's say we're going to start from benzene and we want to put on each group individually onto a separate benzene ring. So I guess we'll take the chloride first. If we want to take benzene and turn it into chlorobenzene, the reagents we use to do that are just some diatomic chlorine, and then as a catalyst, AlCl3 aluminum chloride. And what that will do is substitute one of our hydrogens for a chlorine. Okay, so that's how we're going to install the chloride group. What about the nitro group? So this nitro group is written O2N because it's sort of backwards. It's coming off the left side of the ring. But we also know this as an NO2 group. Same thing, just written slightly different because the nitrogen atom is what's attached to the benzene ring. Okay, so how do we go from just benzene and put a nitro group on to make nitrobenzene? Well, the set of reagents we need for that are nitric acid and also sulfuric acid. There we go, there's nitrobenzene. And then finally, we also have to put on this acyl group here. So the reaction that we use to install an acyl group is the Friedel-Crafts acylation. So let's do that one. Again, starting from just plain benzene. And to do a Friedel-Crafts acylation, we need the acid chloride of that acyl group that we want to add. So we're adding a group with 1, 2, 3 carbons. This acid chloride or acyl chloride needs to have 1, 2, 3 carbons. All right, so that's good. And like the chlorination reaction that we've done up here, the catalyst is going to be AlCl3 aluminum chloride. So that's how we attach that group. Okay, so at this point, we know how to generate a benzene ring with the attached groups, each of the groups that we want. But the problem is we don't want to do these three separately. We want to do them all together and make one molecule that's got all three groups on it. So if you want to just take a guess of which group you want to put on first, that's a reasonable way to do it. And in this case, there's roughly a third chance that you'll pick the best one first. But we can do a little bit of analysis on our starting material here to kind of figure out what might be the best idea. So in order to figure this out, we're going to need to consider the ortho, para, and meta-directing properties of the groups. So the chloride group is a weak deactivating group, but it's actually an ortho-para director. So that's one of the weird, unusual exceptions. but a chloride is an ortho-para-director. If we look at the rest of the ring and the substitution pattern relative to the chloride, we've got the nitro group that's at the ortho position, and then the acyl group is at the para position. Okay, so that actually looks like a pretty good candidate for something to do a lot of directing, because the groups that have been attached are at the positions that it directs towards. So that's good. Okay, what about the nitro group, the NO2 group? That's a very strong deactivating group and a very strong meta director. So let's look at the relationships to the nitro group. All right, the chloride is ortho to the nitro group. So that means that we probably want to put the chloride on first before the nitro group, because we've got a nitro group here. That's going to push any incoming substituents toward the meta position. Okay. Now the nitro group is meta to the acyl group. Okay, that's good. That means that we could install the acyl group after the nitro group, because the nitro group would direct an incoming group to this position. Okay, and finally, we'll consider the directing properties of the acyl group. Similar to the nitro group, it's a deactivating group and a meta director. And so that means that it's going to favorably sort of push other incoming groups toward the meta position. So that's here and also here. Okay. So what should we do? Well, we said at the beginning that the chloride is an ortho-para-director, and it's got a group that's ortho to it and a group that's para to it. So I think that seems like a fairly good candidate for what we should install first. Okay, so I'm going to make a copy of this, put it down here. All right, so here's our target molecule. Okay, so we're going to start from benzene because we're instructed to start from benzene. And we're going to put the chloride group on first. Okay, so if we come up here, how do we do that? Well, we do this reaction. So let's just take this, put it down here. All right, so there we go. That's going to be our first step, is we're going to convert benzene to chlorobenzene. Now, the way I've drawn this is slightly different from how the target material has been drawn. So actually, why don't I go ahead and make it look a little bit more like the target by putting the chloride down here. Now, remember, there's no difference between the chloride being down here and being up here because it's the same molecule, right? We haven't attached any other groups to it yet. And I say yet because that's what we need to do next. All right. Now, in this case, we actually have two options. It would be pretty much equally correct to do the nitro group or the acyl group next. And so I think what I'll do is actually write them out, or write out both syntheses so that you can see that there's really sort of two correct answers to this. Okay, so why don't we do the acyl group first? Okay, so this is going to work because the chloride here is an ortho-para director, so it's going to direct to the ortho position, which is there and also there, and then the para position, which is on the opposite side of the ring. Okay, so to do our acylation reaction, we need this set of reagents. Nope, that's not what I wanted to do at all, is it? Come on. Copy. Paste. Thank you. All right, so there's the acylation conditions. All right, so we know that the chloride is an ortho-para director. And so in this case, when we've got two different options, we get to sort of, pick and choose. We get to cherry pick where exactly our incoming group is going to go. So we want it to go at the para position. So let's make that happen. There's our chloride. And now what sort of group is going to be installed? Well, there's our acyl group. So it's going to look like that. There we go. So now we have a para-substituted molecule like this. And now we've only got one more group we need to install. That's the nitro group. Okay, So if we look at these directing groups, the chloride is an ortho-para director, so it's going to direct to the ortho groups that are here. The para position is already taken by the acyl group, so it's only going to direct to the ortho position. On the other hand, the acyl group is a meta director, and so it's going to direct to the positions that are meta to it, which are here and here. Fortunately, that's the same position, so both groups are directing any incoming group to the same position. Okay, so if we do a nitration reaction to this by using nitric acid and sulfuric acid, the nitro group is going to be directed to that position. And so there we go. The nitro group is installed at that position, and then we've got our target material. Okay, I said I was going to do the other option too, so let's do that as well. Okay, so for this second synthesis, got room here. Okay, so this is going to be route 1, and this will be route 2. Okay, so let's take our first step here. That one's going to be the same. So I'll put that down here. Let's also take our target molecule so we can remember what we're trying to make. Okay, so the first step, the second step that we did in the first synthesis was to do the acylation reaction. And I said that we could also do it the other way around. We could do the nitro group first and then the acyl group. Okay, so let's do the nitro group next. So again, we're going to use nitric acid and sulfuric acid for that transformation. And then again, a chloride is an ortho-para director, and so we get to cherry pick whether we'd like it to do ortho or para. In this case, we want it to ortho direct because we want to install our nitro group at the ortho position. There we go. Okay, and then the last remaining thing is the acyl group. So the acyl group is para to the chloride. That's good because the chloride is an ortho-para director, so it'll direct to that position. And it is meta to the nitro group. And again, that's good because the nitro group is a meta director, so we've got both groups pushing any incoming substituent to that position. Okay, and so to do this final reaction, the reagents we need are our acyl chloride or acid chloride and an aluminum chloride catalyst. And so if we do that, that's going to install the acyl group at that position. And there's our target molecule. All right, so there's our 2 routes for the synthesis of that tri-substituted benzene derivative.